Greetings, class. Welcome back to our continuation of the look at the OSI reference model. So previously we ended up where we were looking at this slide, where we're looking at the functions of the transport layer. And the functions of the transport layer is listed here with service point addressing. By this we mean when we are operating computers, you realize there are several programs or several processes that are running at the same time. And to ensure successful delivery of messages from source to destination, that is on one computer to the next, you realize that sometimes we are delivering a message from one process running on one machine to another process running on another machine. And those messages or that information has to what? Arrive or get to the destination process correctly. So the transport layer header in a network model must therefore include the type of address called a service point address or a port address corresponding what? To the destination machine. So that is what we mean by what? Service point addressing, where we are saying the transport layer header in a network model must include a type of address called a service point address or a port address, which corresponds what? To the destination what? Machine. Then we have the function of segmentation and reassembly. This is where a message is divided into segments, with each segment containing what? A sequence of numbers. So these numbers enable the transport layer in a network model to reassemble the message when they arrive at the destination. So we're saying because our message chunk might be huge, for it to be successfully transmitted, it might need to be broken into parts. Then it is what? Dispatched over what? Over the network. So these numbers will enable what? The packets to be identified. And those that are lost, they can also be identified when what? The message arrives. So segmentation and reassembly is what? Assisted by what? By this numbering sequence. Then we have the other function of connection control. So the transport layer in a network model can either be connectionless or a connection-oriented. A connectionless transport layer in a network model treats each segment as an independent packet, and it delivers it to the transport layer in the destination machine. So when we are using a connectionless model, each segment is treated independently, and so is what? The way it is delivered at the destination machine. Apologies for that. Then in a connection-oriented transport layer, unfortunately, this machine seems to be misbehaving. Let me just try to address this so that it doesn't keep popping up. Let me see. Try to close these windows. All right. Hopefully it won't pop up again. Okay, so we were talking about connection control, where we're saying in a connection-oriented protocol or transport layer model, A connection has to be established first with the destination machine before the delivery of packets commences. So you can see where, like I said, we have two forms of connection control, which are connectionless and connection oriented. In connectionless, each segment is treated independently. We don't have to wait for connection to be established first before we start transmitting. While in connection oriented, connection has to be established first before we start transmitting. Then the next item is flow control. So just like in the data link layer, the transport layer in a network model is also responsible for flow control. And in this case, this flow control is performed end to end rather than across the link, as is the case in the data link layer. And lastly, we have error control, where the transport layer tries to minimize or reduce the number of errors that occur as we are transmitting our messages. However, the error control at this layer is performed on a process-to-process basis rather than across the link. So the transport layer in this network model ensures that the entire message arrives at the transport layer at the other end without errors. That is one, without damages, without loss, or without duplication. So that is all we can say for now about the functions of the transport layer. Let's move on to talk about the session layer. Basically, the session layer is there or is responsible for the establishment of communication sessions. So it establishes, it maintains, it synchronizes the interaction or the communication between communication systems. So when you say you want to talk or you want to ask someone out and you are afraid of going direct to talk to that person, you might need the session layer to come up for you and ensure that it establishes a dialogue session between you and the person you want to ask out, and it ensures that there is synchronized communication, you have established rapport, and you can begin talking, so that there is dialogue between the one in fear and the one who wants to be talked to. So that's the establishment of session that we are talking about in communication systems, so that different systems from different environments can be able to communicate. So this is basically what the session layer does. It is responsible for the establishment of sessions. And I think this sums it all up here. It establishes, it maintains, and it synchronizes. Then we move on to look at the presentation layer. This layer is basically concerned with the syntax or the semantics of how information is exchanged between two systems. So it is responsible for one, translation processes. So if two systems that are exchanging information in the form of characters, strings, etc., they might be communicating using what I would say different bit strings. And this needs to be translated into a common bit stream. And the transport layer is there to ensure what this translation is done. So because different computer systems might use different, or in fact not might, they use different encoding systems. The presentation layer ensures that these different encoding systems are translated into a similar coding system so that the two communicating devices are able to interact and exchange information between them. When we are transmitting sensitive information over a communication network, you don't want it to be transmitted as plain text, which anyone can easily snoop into and listen to. So the presentation layer also provides encryption services to ensure there's data security on the information that we are transmitting over a communication network. Then compression is the other function. So we've talked about two functions of the presentation layer: transmission, encryption, and compression. Obviously, systems are data conscious, and the amount of data that a system or a computer system releases is usually too huge for it to be transmitted in its raw form over a communication network. And this data needs to be packaged or compressed so that it's packaged in a way that it is able to be transmitted over over a communication network. So the data compression reduces the number of bits contained in an information. And this data compression also becomes important in the transmission of multimedia text, that is videos, pictures, etc. You know, these are by their very nature, especially in these days where technology is improving, they are huge in size. And the compression that is provided by this transport layer enables them to package in a way that they are able to be transmitted over a network. So I think this should be the last layer of the OSI reference model we are going to talk about. I remember when I was doing this course and we were looking or trying to remember the various components or the various layers of the OSI reference model, we had acronyms that we used in trying to remember the layers of the OSI reference model. And one of them was all people seem to need data processing. You know, when you are writing an exam, sometimes all people seem to need data processing. These are all the layers of the OSI reference model, where the O here is referring to the application layer, the presentation layer, the session layer, the transport layer, the network layer here, the data link layer, and the physical layer. So this is how we would claim the various layers of the OSI reference model when we are about to go into an exam. And I think you can also make use of this. I think there was another one. That one I never used it, but I think it's please do not throw something like sources picture away. But this is one that I'm familiar with. All people seem to need data processing, where you know your A is representing the application, the P representing the next layer, the S, the session, the T. So this is how you can try to remember the various layers of what? Of the OSI reference model. The application layer enables users to interact with what? With various communication system or computing system by providing user interfaces. So basically the application layer, these are the things that we are seeing what on your desktop. The applications that we are using to send and receive file, to compose file, to connect to the network. So this is basically what the application layer. What I'm using here is what the application layer, the applications that are provided by what? Communication and networking systems, for us to be able to what? To interact in a way that we understand. These GUIs are what we understand, and this is what the application layer provides. So some of the services are broadly categorized as what? File transfer and access, mail services, document formulation, audio services, etc. All those applications that we use are what make up the what? The application layer. Advantages of what? Of the OSI reference model. The layered architecture, it makes the model simple and easy to understand. And the OSI reference model has provided a general purpose reference model that can be used in most communication systems. And it also supports what? Connection-oriented and connectionless services. In terms of disadvantages, because of its inability to fit protocols, it has been replaced by what? By the TCP/IP. So this one is just a model. There are any protocols that are what? Fitted into this model. That's why it has remained more of a theoretical model. Then the other disadvantage, the session and presentation layer does not provide high-end functionalities. Connection-oriented and connectionless services are less supported. So these are some of what? The disadvantages of what? Of the OSI reference model. And this is more of a summary of what? Of the OSI reference model. Like I said, the application layer, I'm using these applications, the PowerPoint, whatever software that I'm using to what? To allow me to access what? Network resources, the web browsers that I'm going to use. All those are what? Are the applications that are what? Provided by the application layer. When I have created my email message on my browser, it needs to be translated, encrypted for packaging into what? Into the network for transmission. So I've drafted my email. It cannot be transmitted as plain text for obvious reasons, for security reasons. So it needs to be packaged ready or in a format that is securely transmittable. And for this format or package to be securely transmittable, a session or a communication session has to be what? Established. And when this communication session has been established, then the data needs to be what? Transported in a reliable way over what? The communication link. So this data being transported over the communication link has to move from source to the destination. And from there, when it arrives, that is when it leaves the source to the destination, the data has to arrive or has to be transmitted. Even if it's transmitted, it loses its format along the transmission. It has to arrive at the destination in an orderly way. So the data link comes in, what to organize the data packets, the frames and the bits so that they are transmitted in what in an orderly way. And lastly, the physical layer provides what the specifications for what for the data transmission hardware wise. So in summary, I can say what this is what the OSI reference model for you. Thank you very much for listening. Now we want to move on and look at what at the TCP/IP model.